I'm now going to be generating some terrain to work with. I'll need to create two types of terrain geometry. One is going to be a typical procedural mesh, where we have geometry, and we deform that geometry. The other is going to be generated using a height field. I'll be starting with the geometry method. We'll then do the height field after that. I'll need a geometry node. I'll rename this node to Geometry Terrain. I can then convert this into a digital asset. I'll update my preferences for this asset. I'll then open the Create Asset menu again. I'll see if there's any more changes which need to be made. I'll then apply my changes and I'll accept. And the asset can now be created. Since this is an object level HDA, there'll be quite a lot of extra parameters. All of these can be hidden. So now I'm ready to generate my terrain. I'll get a copy of the Tommy mesh. Once again, this is primarily for scaling, and Tommy is useful as he has a good height, so he will match my physics settings. For my terrain, I'm going to get a grid. One of the default nodes which is often used for terrains is the mountaintop. And in the previous versions of Houdini, the mountaintop used to give very good default deformation. This mountaintop is not the same as that. This is actually just a variation of the attribute noise node, and it's not going to give me the same effect as the previous version of the mountaintop. So instead of trying to use the mountain node, I'm going to build this by hand. To do this, I'm going to use a point VOP, and this will give me more control over what I'm doing. So what we're going to be doing is we're going to be updating the point position. So I'll connect the point position in the input node to the point position in the output. Currently, however, this will not work very well. There are a couple of issues here, and these pertain to the mesh itself. The first is that it's too small. This should actually be a little bit bigger. So I'll increase the size of the grid, and this will now be a 50 by 50 grid. We now have the issue that we do not have enough geometry. I'll increase the geometry here to be 50 by 50. I probably could raise it a little bit, but I will keep this light as I'm trying to test things currently. The main point of this is actually not to make large landscapes. Various parts of our level design could have geometry which is not necessarily flat, and we do not want to restrict this to purely be working on height fields. I need to test the controller on general geometry as well as height fields, as I want to be able to handle both. So this geometry is not necessarily for landscapes. We will still often need to have geometry for a floor which is not being defined by a height field. For example, in building interiors, particularly in buildings with indoor gardens, or dilapidated buildings and ruins. We'll be modifying this topology with noise, and there are a number of options for noise. Unified noise is probably the most flexible, but it is not the fastest node, as it contains most of the noise algorithms within it. Instead, I'm going to use anti-aliased noise. This noise will be based off our point position. For an idea of the noise output, we can connect it to our color. Currently nothing is showing up. This means that I haven't activated the display on my VOP. I'll activate it now. We should now be able to get an impression of the kind of result we'll get from this noise. So we'll want to use this noise as a map for displacing our points, and the easiest way to do this is to use a displace along normal node. We could do more complex things with this, but we don't really need to for what I'm using this for. We'll need to displace our points. We should also actually add normals to this, and feed the normals into our displacement node, but I haven't actually added any normals yet, so I can remove this connection for the moment. The displacement is displacing our points, so I'll connect the points in the displacement to the points on our output. I will also displace the normals. I'll then set the amount of displacement with the noise. And we should now be modifying our geometry. I'll open the parameters for the VOP, as I will want to expose some of these parameters within the interface. The first of these parameters is the scale. This will influence the distance of the deformation. For example, we could set the scale to 100 and we can see the results here. So this is one of the parameters which we will want to expose. We can expose this in numerous ways, but for the moment I'll get a parameter node. I'll call this parameter scale. I'll give this a float range from 0 to 1000. This is a reasonably arbitrary number, and it wouldn't be enough for actual landscapes, but it is more than enough to test with. We do not want this to have a locked float range. I can connect this parameter node to my scale input, In our parameter interface, we should now have a scale parameter. We should now be able to drive our scaling through the interface. The next thing that we want to do with our noise is we want to drive the frequency. The frequency is way too high for what we need by default. I'll want to set this to a reasonably low value, for example 0.0001, and I'll want to do this for all three axes. This is a much lower value, but it gives us a much more natural and navigable terrain to start with. By default, this uses Perlin noise. I'm going to use simplex noise instead, as I prefer simplex noise for terrain. I'll need a parameter to drive the frequency. This parameter will be called frequency. I can also set this to be a value from 0 to 1000. Using a higher number will make this slightly easier to deal with. We will not, however, be linking this parameter directly. Instead, I'm going to get a float to vector node, and I'll set all of the float values here to be 0.0001. So this will give us the default vector for our parameter. This node will be connected to our frequency input in the noise node. We'll then get a multiply node, and we're going to multiply this value by our parameter. This should give us a bit more control over our frequency. I can then test this parameter. 1000 is probably a bit high for this parameter, so I'll limit this parameter to be 100 instead. We can now use this to give ourselves a basic landscape. This should allow us to make reasonably large-scale landscapes, but more importantly, it will allow us to make smaller landscapes, where I can test the finer details of my traversal system. So this should give us our first and most basic landscape tool, and I can now update the HDA for this landscape. So we'll need to open the type properties. At the top level of this node, I'm going to add an output. This is not necessary, but it does guarantee the functionality of this node. Essentially, it means that I can work on this network and change the display of nodes, and not have to worry about the final node being marked as the display node before exporting the HDA. I can now start setting up the parameters for this node, and I'll start with parameters from the grid. The first parameter that I'll add to my interface will be the size. I will also want the rows and I'll want the columns. After this, I'll work with the parameters for the VOP. Here we have two parameters, which are the scale and the frequency, and both of these can be added to our parameter interface. I will add a couple of folders to my interface in order to organize it. The first of these will be for our grid. As this is going to be used in Unity, this will be a simple folder. The second folder will be for our noise. I'll move the parameters into their respective folders. I can then open the Channels tab and I can set defaults for some of these channels. I want the scale to be noticeable, so I'll set this to have a default of 50. I'll set the frequency to be 10 by default. I can then apply and I can save my node type. I'll update the icon for this node, and I'll specify this with SOP height field. Even though this node is not technically a height field, it is still a terrain style icon, and I do not need to make any custom icons here yet. I can then save my node type, and I can export to Unity. In Unity, I should now have a terrain folder. I can open this folder. I can drag and drop my terrain onto the scene. I can press play, and we should see that my player's scale matches what I had in Houdini. I should have parameters on this HDA. I should be able to adjust the scale of this node. I should also be able to adjust the frequency. So this will give me a basic terrain to work with, and this is for geometry terrain. Next, I'm going to work on a height field terrain. So I'll return to Houdini. Here I'm going to create another HDA. So I'll get a geometry node. I'll call this node terrain. This will be a height field based terrain. I'm going to convert this into a digital asset. This is an object level HDA, and it was created off a geometry node, so it will have parameters by default. I'll select all of these parameters and I'll hide them. I can then apply and I'll accept. I will want to set the icon here as well, so I'll reopen the type properties. The icon here will also be SOP height field. I can then enter this node. First we'll get a height field. For Unity, the height field should have a size which is a power of 2. If we have in a texture, this should be a power of 2 plus 1. For the height field, I'll have 1024 as the default. If this was a texture, this would be 1025 as the size. I'll use 1024 as my test size. This will be purely for testing. If we get to using the actual terrain, this will become far more complex. I want to make sure that this is sampled by center. I'm going to set the grid spacing to be 1. So that will give me my base height field. I want to modify this, and I'll modify this with noise. Specifically, I'll use a height field noise node. And this network here is going to give us our initial height field. So I can open the type properties for my HDA. For the moment, I'll add 2 parameters to the interface, and those will be amplitude and element size. I can then apply, and I'll save my node type, and this HDA can now be exported to Unity as well. I'm back in Unity, and I should now have my terrain HDA as well as my geometry HDA. I will need a new scene to test the terrain HDA in, so I'll go to my scenes folder, and I'll duplicate my test scene here. This will be called Test Geoterrain. I'll duplicate this again, and this will be my test terrain. In this scene, I'll remove the geometry terrain, and then I can add my height field terrain to the scene. We now have a height field in our scene, and we can play the scene, and this will allow us to see the height field in the context of our player. So this gives us 2 basic terrains to test with. There is one more change I want to make with this terrain though, and that is to give this terrain a material. I'll go to my materials folder and I'll add a new material. This material will be called Terrain Default. I'll set this material to be an HDRP Terrain Lit material. In the Houdini dropdown, I'll go to my plugin settings. I can now update the default terrain material, and this will now be my terrain default. So that will give me basic terrain to work with. We'll need to update our character to conform to terrain. We will also want to create the basic geometry to test our buildings, so we'll be working on those next.